Okay, in this video I want to go over how to find the domain of the sum, difference, and the product of functions. Now note that we have two definitions here. The definition of intersection, which is denoted by this little symbol that looks like a letter N, and it is defined to be the set of all the points in common that all of the given sets have. Let's just say you have the set capital A, and the elements of capital A is 1, 2, 3, and the set capital B, and the elements of the set capital B is 2, 3, 4. Well, the intersection of capital A and capital B is all of the common elements that both A and B has, which is positive 2. Now, the second definition is the domain of the sum, difference, and product of a finite amount of functions, which is defined to be the set of all of the x values in common that each function's domain has, as well as of all of the restrictions, aka excluded x values of each domain. And remember that restriction and or excluded x value is a specific x value that would make a function undefined when you plug it into a function. So you want to make sure that when you do your work, you want to exclude all of the x values that would make any one of the functions in any one of the steps undefined in order for you to be able to do the problem entirely. So let's go through finding the sum, difference, and product of example number 1. So in example number 1, we are given f of x equal to x squared minus x minus 3 and g of x equal x plus 1. Well, looking at these two functions, both of them don't have denominators, so they don't have any point of discontinuity. So we get to say that the domain of each of these functions is all real number. Hence the open interval from negative infinity to positive infinity. So let's find f plus g. F of x plus g of x, but I'm just going to put f plus g, which stands for the simply. Well, f plus g is going to be what? Well, positive f plus positive g, which means these two functions are going to stay the same. So we have 2x squared minus x minus 3 plus x plus 1. Combining like terms, the minus x and the x cancel out. Negative 3 plus 1 is negative 2, so this equals to 2x squared minus 2. And then factor out a little more. This will be 2 times x squared minus 1. But take a look, this quadratic expression is a special form of the difference of the two squares, because this binomial can be rewritten as x raised to the second power minus 1 raised to the second power, so the difference of the two squares. And this can be factored out to be 2 times x minus 1 times x plus 1. All right, let's find the difference. So we get f minus g equal, well, positive f is still gonna stay the same. So 2x squared minus x minus 3. Now we have minus g, so we want to make sure that we put the g function inside the parentheses. X plus 1. There we go. And the reason why we want to do that is because the minus sign in front of something usually indicates the invisible negative 1 number. So distributing this invisible negative 1 number in, we are going to have 2x squared minus x minus 3 minus x again, and then minus 1. Well, combining like terms, negative x minus x is going to be negative 2x. Negative 3 minus 1 is going to be negative 4, so we got 2x squared minus 2x minus 4. And the difference can be factored out to be 2 times x squared minus x minus 4. Oops, minus 2, my bad. But then we're not done, because this expression can be factored again into two binomial factors. So looking at the first term x squared, we know that the multiplicative factors of x squared is just positive x and positive x. Two numbers are multiplied together to give me back the last term negative 2, and the second coefficient negative 1 is going to be negative 2 plus 1. So this is the factor form of the difference of the two functions. Now, what about the product? Well, the product is going to be f times g which is 2x squared minus x minus 3 times x plus 1. Well, this is going to require some distributing. So let's distribute this whole thing to each term inside this parentheses. So we are going to have 2x squared times x plus 1 minus x times x plus 1 minus 3 times x plus 1. Then at this step, we just distribute 2x squared in here and doing the same thing for these. Distributing the minus x into the x plus 1 and negative 3 into the x plus 1. So this will give us 2x cubed plus 2x squared minus x squared and then minus x and then minus 3x then minus 3. Combining like terms, keep the 2x cubed. 2x squared minus x squared is just going to be plus x squared. Negative x minus 3x is going to be negative 4x minus 3. And I don't think we can factor anything else from here, so we are good with this. Now, what is the domain of the sum difference and the product? Well, let's find the domain of a sum first. And the domain of the sum if you take a look, the sum here has no restriction at all because it has no point of discontinuity. And the reason why it has no point of discontinuity is because it doesn't have any denominator. And also, as mentioned earlier, the function f and g, their domains, also don't have any restriction. They don't have any like x not equal to whatever. So that means the domain of f plus g is also going to be a real number. Now what about the domain of f minus g? Well, the domain of f minus g, which is the domain of this result here, it also doesn't have any denominator either. And of course, f and g, as mentioned just now, also don't have any denominator either. So the domains of f and g are again all real numbers because of no restriction. And so the domain of the difference is also all real number, also because of the fact that the difference has no restriction either. And we can say the same thing for the domain of the product, because the product turns out to be this little function. But this function also has no denominator, so it has no point of discontinuity. And of course, f and g, again, have the domain of all real numbers, no restriction whatsoever. So that means the domain of f and of f times g is also all real numbers. Now the way we can look at this graphically is this. Let's say we have a number line like that. We have the function f. We have the one in red here is the domain of the function f. So this is capital D sub f. And the one in the green is the domain of the function g, which is also all real numbers. To come up with the domain of the sum of these two functions, the domain of the sum of two functions have to include all of the x values in common of each domain and all of the restrictions of each domain. But if we take a look at this graphical representation of both functions' domains, we realize that all of the points, all of the x values that they have in common are really all of the x from negative infinity to positive infinity. So that's why we know that the domain of f plus g has to include all of the points in common from negative infinity to positive infinity. Or should I say all of the x values in common from negative infinity to positive infinity. And of course, we can say the same thing for the difference. Again, looking at all of the x values in the f domain and in the g domain. Oops, this is it. G, not the f. Looking at all of the x values in the f domain and the g domain, they both again, have the common x values, which are really all of the x value from negative infinity to positive infinity. So the domain of the difference is also all real numbers. And of course, by the same reasoning, the domain of the, oops, this is a bad one. The domain of the product is also going to be all x values in common, which are from negative infinity to positive infinity, like that.